All right, you guys. Okay, ready? Are you ready? You ready? You ready? Lindsay, you ready? All right. Class. Oh my goodness. Expect better. Expect better. Anyway, all right. So we're gonna go over this, but the first couple things I'm gonna talk about is just the basis for this question. So right now it's giving me a velocity. So in hierarchy, I'm going to start with my, it's usually S of t, which is my position. V of t is my velocity. velocity. Is that right? Looks like velocity. Anyway. And after that we have A of t, which is acceleration. ACCELERATION. Is that spelled correctly? Okay. So going from one to the other and changing it, so going down this way is a derivative. And going up this way is integration. Right? So that's important. So whenever we're talking about certain things, that if I need to go from one to try and find the position, so given the velocity, so if I'm given the velocity and I need to find the position, I need to do an integration. So if I want to go from my velocity and see if it is accelerating at that point, then I have to take the derivative of my velocity to see what that is. So hopefully starting this out should help with this problem. Always start with the things that you know. And this should be a good outline to help us out. So from there, it says at time t, oh wait, hold on. Okay, for t is greater than 0, particle moving along the x-axis, the velocity of the particle at time t is given by v of t there. The particle is at position x equals 2 at time t equals 4. Now, this is something that's going to look like this. So this is time, and this is my x position. So as I'm going this way in my coordinates, so 0, 1, 2, 3, 4. Okay. Because they give us information here. And then it goes up 2, right? Something like that. Okay, particle is at position x equals 2 times 4. So that means that I have a coordinate right here. And that is 4, 2. So now all I'm doing is just listing out all the information from this. So let's go through and start off. It says that time t equals 4, the particle is the particle speeding up or slowing down? So is it speeding up or slowing down? So first thing I'm going to do is I'm going to figure out what the velocity is. So velocity at t equals 4, and that's going to help me out. So let me restart that one. Okay, so if you guys remember, so think about this. So a positive velocity means that's Denny driving through the school zone going forward, right? Okay, he's doing 45 miles an hour through that school zone, hitting all those noisy speed bumps. Okay, now if it's a negative velocity, he's going through that same school zone, but now he's going backwards, right? So he's still going a speed, but he's just going in a different direction, right? So a negative velocity means I'm going the other way. Positive velocity means I'm moving forward. So that's important. So let's go ahead and actually plug in my thing, since it is a calculator available. Plus 2 sine of x squared over 2. There it is, right there. Now, it looks kind of crazy, but what can I get rid of now? What was my initial condition? I start at 0, right? So the whole left side of this graph, I can get rid of that. So let's change our window to make this a little bit easier to read. So 0. All right. We could leave it at 10. There we go. So there we go. Starting out. So now, given the calculator and all the amazing things my calculator can do, all I want to do is find out what is v of 4, right? It's asking for v of 4, the velocity at t equals 4. Right here, at time t equals 4. So we're just going to plug that in. So, menu, graph trace, and right here, since it gives me a coordinate, I just want to plug in the number 4 and hit enter. My value is going to be a positive 29787. That's important. Let's write that down. So for my first one, my v of 4, 2, like that, right? Yes? Okay, good. Now that's my velocity, and it's positive, isn't it? So going back to my analogy of Denny driving through the school zone, which way is he going? Yep, he's going forward, right? Now, let's find the derivative at that point. Now, since I graphed this one here, hopefully you could actually kind of see it there. I can kind of see it there. But I'm going to actually tell my calculator to just do it for me. So, menu, 6, and we want to figure out the dy dx, right? The derivative. So that's option 5. And at point 4. So plug in a 4, hit enter. And that's going to give me a negative 1.164. So that's going to be v prime of 4. Now, what do you think that means? If I have a negative velocity, what does that mean? No. Negative velocity is going back, right? Yes, you're correct there. Okay, positive velocity, I'm going forward, right? But now, if I'm still going forward, but I have a negative acceleration, what does that mean? I'm slowing down. If I had a positive acceleration, I would be speeding up. So right now, given this information that I have a positive velocity, I'm going forward, and a negative acceleration means I'm slowing down. If I was going the other way, if it was a negative velocity and a negative acceleration, I would be speeding up in the other direction. Does that make sense, Denny? Okay. Just remember that when you hit those squeaky speed bumps, okay? So right here, at time, is the particle speeding up or slowing down? So this particle in this one right here is going to be slowing down. So, and for my reasoning, v of t is going to be positive, and v prime of t is negative. So when the signs are different, it's going to be slowing down. If the signs are the same, it would be speeding up. That makes sense? Okay. So hoping you guys write this down, because to get your 2 points, you need to actually have all this information right here. To get 2 points on this question, you have to have all those. Next one is going to be B. Find all times t in the interval from 1 to 3 where the particle changes direction. So, for where the particle changes direction, I'm going to make a new slide for this one. So, particle changes direction. So, what do I need to figure out? I have the graph right here. What is that going to tell me? So if I want the particle, so I have the velocity. So when the velocity becomes 0, or crossing the x-axis, that's where it is going to change direction, right? So all I'm going to do is just find a 0 here. Find that 0. So on my calculator, I'm just going to hit menu, okay, analyze graph, and 0. So I'm going to move over here. Ah, dang it. Upper bound. So I have a 0 right there. Now, I got to look to see, because it gives me a bounce from 0 to 3. So I got to figure out what this other coordinate is also. Dang it. So that's that coordinate right there. Menu, analyze graph, 0, and let's see what this other one is here. So that's beyond 3. So that one right here is beyond 3. So I'm just looking from 0 to 3. So any places that change direction? Only one place, right? Where t is going to be equal to 2.707, yeah. Because for this test, any approximation needs to be to the third digit. So 2.707. Does your calculator not say that? So this is what you're going to do. Menu. Settings. And see this right here? Display digits. And I just changed the float 7, because why not? It shows a lot more digits, but it's going to gunk up your screen. Just clear off your screen in between each one. There you go. Does that make sense or no? Are we good? Denny, did you find it? Lindsay? So 2.707. There you go. So my velocity is going to be equal to 0 when t is 2.707. So that's where it's going to change from a positive to a negative. So that means my particle is moving forward, then changes to particle moving backwards. Now the next one, let's go back a little bit. C. Oh, justify your answer. Let's see. Okay, we did for that one right there. And find the position of the particle at time t equals 0. Now, this one right here has to do with this graph, but I'm going to move this graph to the next page. So I have the sketch of my graph. So what it tells me, so at this point was 4 comma 2. There you go, 4 comma 2. That's that point right there. So I'm going from a velocity to an integration, right? Yes. I'm going from a velocity to an integration because I want to find the position, going back over here, I want to find the position, so I need to go up to and do an integral, and I have a starting point of 4, 2. So since I have this one right here, what I need to do is, let's say it is something like this, right? Boom. I'm just making up what this graph is because I suck at drawing. So this is the graph of the velocity, and I need to find the position now. So from there, I know that my integral would be from here, from 0 all the way to 4, right? Because I want to try and find out what it is at 4, or I'm sorry, at 0. I want to find out what it is there. But I know what it is right here. I know what this location is. So what do you think I should do with my integral here? If I'm moving along this way in my function, what do you think I should do with the integral? I'm trying to go backwards here. Take a guess. Elizabeth, you want to take a guess? If I start here and I want to end up over here, what should I do? Am I going backwards? Okay, what do you think I should do if I'm going backwards? Should I subtract that? Yeah, it's going to be a subtraction. Because I'm finding the integral right here, so I'm subtracting because I know the velocity to get here, but I need to find the position, which is going to be the antiderivative of the velocity. So my starting point is up there at 2. My starting point is at 2, then I'm going to subtract the integral, and that's going to give me some point way over here. That's going to give me some point over here. So my integral is from 0 to 4 of my function 1 plus 2 sine of t squared over 2 dt. Okay. All right, let's see what I get here for this one. So I'm going to do the math and just get the calculator to do it for you. Because I started here I had a value of 2 here, and I'm subtracting all this to go backwards because I want to find some point over here where x equals 0. So like I said, get the calculator to do it for you. So I'm going to have this 2 minus integration from 0 to 4 of 1 plus 2 sine of x squared over 2 dx. So by showing this much right here, this is all I need to show that much of what my work is, I get a negative 3.815. Because this is the graph, it is in terms of t, my time, and the x's going up and down. I know it's kind of weird. X is my position, right? In terms of time. And now my last one that I have is part D. Find the total distance. Now, with the velocity, is it going forward and backward? So yes, it is going forward and backwards. But again, we have Denny. He's driving through that school zone. Okay, he went forward through the school zone and decided to go backwards also. So, but since he's still using gas in that car and he's still traveling a distance, even though it's just going in the other direction, this area down here below represents Denny going backwards. So he changed direction right there, and he went backwards, and then he changed back direction and started going forward again. So what we're going to try and do is, it says, find the total distance traveled from 0 to 3. Now, total distance. So I could actually go from here to here and then subtract here to 3. I can do that because total distance, because everything below the line is going to be a negative distance, right? And I'm going to show you integral. So starting at 0, and if you look right here, look at how the values keep going up. Keep going up until I get to this point right there, and then it starts going down because it starts adding a negative right there too. So total distance is going to be positive. How do I tell my calculator, or how do I say in math I want it always to be positive? Very good. Absolute value. So for this one, I would go to here, and I'd have this value. I would do it again from menu, analyze graph, integral from that point to 3. So I could do it like this and have this minus this value. So I would be adding these two numbers together. So I could do that by showing, okay, I stopped here, I went all the way to 3 in there. So if I put these two together, that's going to be my answer. Or I could just go back to this and go, I want to find the integral from 0 to 3, absolute value. So if you hit the little right here, it's below delete. This is the absolute value bars. 1 plus 2 sine of x squared over 2 dx. So my total distance traveled should be 5.310. Or I could look at my graph again. So 5.1369 or minus my negative. My other graph is negative 0.1642. So now, by doing this here, I get the same answer what I had over here. Both of them is going to give me the same answer. So, which one is easier? Whenever I want total distance, make sure you use the absolute value, especially if you have your access to your calculator. It will do it all for you. So I get 5.310. Total distance. All right, that's it. Make sure you guys all like, share, and subscribe.